Hi, this video is Lesson 7, Next Year's Gig. This is a Solidify Understanding task. So let's go ahead and begin by reading the story. One reality of the NC State Fair is that planning for the next year begins. This year's fair is over. Fair officials have already started looking at new bands to entertain next year's fairgoers. Johnny Baldridge and the Piedmont Boys, as one of the acts of the NC State Fair planners, are considering for next year's fair. At a recent concert, 1,000 fans spent $20 per ticket. Market research suggests that for every dollar a ticket price goes up, 10 fewer people would come to the concert. The profit J of X from the concert can be modeled by the function below, where X represents the number of $1 increases in the price of a ticket. So J of X equals 1,000 minus 10X times 20 plus X. So now we're going to break down the equation and decide what each part represents. So what does the 1,000 take away 10x represent in the context of this situation? So in this situation, the 1,000 is going to represent the 1,000 people who went. So the 1,000 ticket buyers or showgoers. And then the 10x represents, so that's the 1,000. The 10x represents that you're going to lose. So for every $1 increase, you'll lose 10 people or 10 ticket buyers. Then the second part of the equation says 20x. So what does the expression 20 plus x represent in the context of this situation? So then from there, I'm just going to try to choose a different color. 20 is the original ticket cost. So 20 is the original ticket cost. And x is the price increase per $1. Per $1. So we'll do some examples down below. So J of 0 means that they have not increased or decreased their ticket price. So it's the same $20 that it was last year. So what would be the profit if they kept the ticket prices exactly the same? So we're going to use the equation from up top. So J of X equals 1,000, take away 10x times 20 plus x. So if we do not increase it, we're going to put 0 in for x. So this is going to be replaced with a 0, as is this. So if we do that, then you'll have 1,000 minus 0 times 20 plus 0. And that's going to give you 1,000 times 20, which is $20,000. So they would profit $20,000 if they do not increase their ticket prices. So number 4 is saying, all right, instead of doing $0, let's do a $30 increase. So 30 does not mean that it's going to cost 30 for the ticket. This means that it's a $30 increase. So this means $30 increase. So really what that means is that the tickets now cost $50. But we're going to still use 30 in the equation. So again, we're going to rewrite the equation. J of X equals 1,000, take away 10x times 20 plus x, because x represents what it's increasing by. And we're going to replace x with 30. So now we have 1,000 minus 10 times 30 times 20 plus 30. Then you could just do order of operations. So 1,000 take away 300 times 50. So 700 times 50, so $35,000. So as you can see, if we increase our ticket price, we're going to make more money. Less people are going to come, but because you're now making more money per ticket, you'll actually increase your profit. But eventually, if you start charging too much, you're actually not going to make any money. So then what if we increase our ticket price by $90? So we've now jacked it up $90 more than it originally was. So we were originally at 20 bucks, now we're at 110. So let's go ahead and write that out. So I'll use green this time. So J of 90. This means that it has increased by 90. So increased by $90. Okay. So then we're going to rewrite our equation, but this time we're going to use X as our 90. So J of X equals 1,000 minus 10 times 90. Here, let me write it like I did last time. So then we're replacing the X with the 90. So our tickets will now cost $110, but now we're losing people. So now we've lost 900 people, right? So, you normally have 1,000 people. 900 people are now no longer coming, but you're charging $110 per ticket. So then you get 100 times 110, and that's only going to give you $11,000. So as you can see, if we go back up to the top, if we don't charge anything, if we charge the same $20, you'll make $20,000. If we increase it up to $50, you'll then make $35,000. You're only getting 700 people to go, but you're making more per ticket. And this one, because we're now charging $90 more, we only have 100 people going at $110 per ticket. But because you have so many less people going, even though the ticket prices are more, you're now way lower than you were previously. All right, so now we're going to type this function into our graphing calculator using the profits $1 adjustments. And if J of X equals 0, find the solutions for X. So that means we're going to be finding our X-intercepts. So what do these mean in context, et cetera, et cetera. So I do have a graphing calculator on my computer, so I'm going to open that up really quick. Okay. Just give it a moment. Thank you. All right, so let's see if I can open back our document, but then have the calculator on top. Perfect. All right, this is my first time using this calculator, so. Okay, so what we're going to do is we're going to go into our y equals, and we're going to type in our equation. So that would be parenthesis 1,000 take away 10x parenthesis, and then it was, I think, 20 plus x, if I remember correctly. 20 plus x. Yes, because you're adding. Yep. Then what they want us to do is they want us to graph that. So if you have your window, normally a window is like -10 to +10, and then it's like -10. I was playing around with it earlier. -10 to +10. So if we graph this, we're probably not going to be able to see our parabola. Okay. So what we're going to want to do is change our window. So I'm going to change our window to be, so if our profits are $35,000 and we're charging, 90 or what was it, 30 extra dollars, we're going to want to change our window. So our X max, if increasing it by $30 gets that really large price, let's maybe go to let's go to 90. No, maybe let's go to 110 actually, so we can see like what happens. And then our Y max, I don't know, let's maybe let's go to $50,000 because right now I know $35,000 is the most that we've seen so far. So then now we can graph it. Okay. So now we can see our graph much clearer. I'm going to actually change my Y minimum so I can see kind of below. So let's actually go to my Y min. Maybe let's change that to be negative. I don't know. Let's make it like 2,000. And then we'll graph that. Okay, so I can kind of see like the x-axis a little bit better. So if we look at the graph, I don't know if I can actually draw on the calculator. No. But if we look at the graph, oh, okay, so I can kind of hold my pen down. I don't know if you guys can see that. But there's a y-intercept right here. My x-max is up here, and then my y-intercept, or my x-intercept is down here. We'll go over those in just a second. So we typed it into our calculator using our profits one. So to determine the window, what do these solutions mean? So what we can write right here is that the windows that we chose, so windows, we chose for our x min was just -10. Our x max, we said was, I think 110. I can't remember. I think so. Our y min, we changed that to be like -2,000. And then our Y max, which we made that to be like 50,000. That represents our money. And then they want us to actually find the solutions, which when they say solutions, what they mean are your x-intercepts. So let's go back to the graph and let's look at the graph and see what we find. So I'm going to actually change my window so that we can actually see the back half of the graph. So I'm going to make that -50. And then maybe we'll make this actually -10,000. Let's graph that. Okay, so that's a much better graph. So I changed my window, guys. I'm going to show you what I did. So my X-Men, I believe I made that -50. I can't believe, I don't even remember right now. And I think I made this -10,000. So that way we could see the whole entire graph. Okay, so again, here's my window. Yeah, so -50 to +110. And my Y min is -10,000 to +50,000. So then when we graph it, we can see everything. We do have two solutions. One solution is not a real solution. It's the one on the left. But the easiest way to find it is this. If you go to your y equals, if you type 0 in for your second graph, and then you graph it, it's going to give you this red line here. And then what we can do is we can find the intersection. So I'm going to do second, trace, and then I'm going to do number 5, which is intersection. And then I'm going to move my cursor as close to the intersection as I can. So you just have to keep pressing the left button. And then I'm going to press enter for first curve, enter for my second curve, and guess for my third curve. So I get -20. Okay, so we'll remember that. So put that in your head. Then I'm going to do it again. So second, trace, number 5. And then this time I want it to be over. Okay, so I just keep pressing. I want it to be over on the right side. I'm just pressing the right arrow. Okay. You probably can hold it down, but this is on the computer, so it's a little different. All right, so then I'm as close to the intersection as possible. So enter, 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 and then I get 100. So our two x-intercepts, which are called your solutions, are at -20 and 0, which this is not real. Okay, because you're not going to charge -$20 for a ticket, or you're not going to, you're not going to start paying people to come to your show, I guess, And then the other one is +$100. So then they asked, what do these mean in context? So remember, the X represents how much money you're increasing it by, right? So this means that I have increased my amount by $100. So I've increased by $100. So now my ticket price is $120. Well, I'm going to make $0 profit. So at $120 for the ticket, it's $0 profit because no one's going to buy it. So no one's going to show up at my show. I'm not going to make any money. If I do -20, same thing, but again, that's not a real answer, so we're not going to worry about that. Number 7, what would be the maximum profit for the NC State Fair, and how many $1 increases would they have to include to get the maximum profit? What is the resulting best ticket price? So again, we're going to go back to our calculator. This time we're going to find the maximum. So the easiest way to find the maximum is you press second, trace, you choose number 4, and then what you're going to want is you're going to want your cursor to be on the left side of your maximum. So I'm on the right side currently, so I'm going to keep moving my cursor until it is on the right side, or excuse me, on the left side, because it's saying I want left bound. So I just passed it, and now, okay, so left bound, press enter. So what my calculator is doing is it's saying, okay, between this line, so this boundary, so we're creating boundaries, and then I'm going to do it again between that boundary. So it's the calculator is looking between those two lines, where's my maximum? And then down here it says, do you want me to guess? Yes, I do. So press enter. And then it finds it at 39.99999, which is 40. So at $40 increase, you're going to make $36,000 profit. So our maximum that we found on the graph, and we'll just do a quick little sketch. So this guy right here was 40 and then $36,000. So what does that mean in the context of this problem? This means that we have increased the ticket price by $40. Okay. So less people are coming, but we're making more money per ticket. So by $40 with a profit of $36,000. So if we put that back into our equation that we did earlier, you can see I'm gonna make this pen just a little bit thinner. If we put it back into our equation, if we have 1,000, take away 40 times, or excuse me, it was 10 times 40. Let me undo that really quick. So 10 times 40. And then that is 20 plus 40. So our tickets are really $60. So we have 600 people going times $60 a ticket, and that's going to give us that $36,000, which is our maximum. So number 8 says, write the function for Johnny Baldridge and the Piedmont Boys in standard form. What information can we easily gather from standard form? So if we change it to standard form, all you got to do is just multiply the number, multiply it out. So we're going to take the original equation, which was 1,000 minus 10x times 20 plus x, and we're just going to use distributive property. So I'm going to go ahead and do a different color. So distribute. So 1,000 times 20 is 20,000 plus 1,000x minus 200x minus 10x squared. So then if I simplify that, I get 20,000 plus 800x minus 10x squared. And then it asked, so what information can we easily gather from this information? So 2 things that you can gather when you're looking at standard form. And these are the 2 easiest things that you can see. Let me change this to black. I'm going to change the order of this to be in correct standard form. So let me change that to this order, please. Okay. So here's some things that it can show us. So I'm going to erase that top part and we're going to write some information. Okay. So what we can see from the standard form is that it's going to be a negative parabola. So it's going to open up this direction because we have a negative sign. We also can tell that this is the y-intercept because the y-intercept is your C value. It's your start value. It's when x is 0. So you're starting at $20,000. So on the graph, if we were looking at the graph, this right here, boop, this would be 20,000. There's your maximum that we found, which was 40 and 36,000. And then this one was, I think, what did we say was 100? I can't remember. Let me see if I can scroll. Yes, $100. So right here. So all those things that we can tell from the standard form is the direction and your starting value, your y-intercept. So then a different band is potentially playing at the fair. So another band that the fair planners are looking for next year is Anna's Animals. Their recent concert also sold $1,000, but fans spent $35 a ticket. Market research indicates that a dollar increase in the price ticket would lead to a drop in ticket sales of 20 tickets. So every time they increase, they're losing 20 people instead of 10 people, but they're charging more per ticket initially. So their form is given to us in standard originally, where the, what was their name? The Johnny Baldridge boys, they were in factored form. So this is called standard form in case you want to write that down. So that's standard form. All right, so what does the 35,000 represent in context of this problem? That 35,000 is the profit that they made last year off the 1,000 tickets. So 35,000, that's the profit made by the 1,000 tickets times the $35 a ticket. So that's their profit. Okay. So then we're going to type this into our graphing calculator. We're going to find the x-intercepts of this, and then we're going to talk about what those mean as well. So let me open up my graphing calculator. And go to y equals. We're going to clear and clear. So then I'm going to go and I'm going to type in 35,000 plus 300x minus 20x squared. All right, we're going to graph it. Maybe the window works from the last one. Maybe we need to make it bigger or smaller, so we'll see. Okay, perfect. It works just fine. I probably actually can make my X max a little smaller if I wanted. So we don't have to go all the way to 110. Maybe I can go to like 80. Yeah, that looks great. Okay. So what we're trying to find is the x-intercepts. So again, I'm going to go to my y equals. In my y2, I'm going to type in 0. It's going to graph a second line. So mine graphed in red right there. We're going to find the intersection. Again, the one that's in the negative section, that's not a real solution. So, but we can still find it. So we're going to do second, trace, intersect. We're going to bring the cursor back. We're going to put it as close to the intersection as possible. Okay. And then I'm going to do enter 3 times. Okay, so negative 35. All right, then we're going to move the cursor back over. Really wish I could just hold the cursor over, but I can't. So second trace, 5. And I need to move that over. Yeah, see, I have to keep pressing it. Okay, so then we're going to move that all the way back over to the other intersection. There's another way to do zeros, but it's kind of annoying, so I'm just going to do it this way. Enter, enter, enter. So I get 50. Okay, so the most that they can increase their ticket sales by is 50. So I think it was what, negative 35 and then 50? All right, so type this function into your calculator. What are the x-intercepts? So the two x-intercepts that we found were negative 30, oops, excuse me, negative 35, 0, and 50 and 0. And what do those mean in the context of the problem? So again, this is not the real one. This is if you were to decrease to negative $35. So you'd be charging basically $0 for your ticket. So this would represent if you, right? No, 0. So this, yeah. So this would be, so you're charging $0 for your ticket. So you would make no profit. So this is if you were increasing by $50. So increase by $50, right? So if you were to do the problem, we would know that your people coming would go down. So your $1,000, or excuse me, your 1,000 people, you're losing 20 people every time. So if we increase it by 50, well, as you can see, if I increase it by 50, that's 1,000 people. Take away 1,000 people. That means that nobody is coming. Well, then you're not going to make any money. So you'll break even and make $0. So that's where the $50, you're going to make no money. So no profit, I guess, is the biggest thing to take away from that. All right, and then what's the maximum profit that Anna's Animals will make for the NC State Fair? And how many $1 increases should they have? How many $1 increases would they have to include to get the maximum profit? So let's go back to our calculator. We're going to find the maximum for this. So second trace, number 5. I want my cursor to be as close to the maximum as possible, and I need it to be on the left side. Did I just do intersection? Hold on. I think I did. Second trace. Number 4. I think I chose intersection. So left bound and right bound and enter. All right, so there is my increase. It looks like it is $7.50, and that's going to give us 36,125. All right, so 750 and 36,125. Okay, so 750 and 36,125. So if they increase by $7.50 per ticket, then their max profit is going to be the $36,125. Okay. So which band would you choose to hire for the NC State Fair next year? I would go with the one that's going to give you the most profit, even though it's only $125 difference. I guess I would go with the Anna's Animals, because if you look back at, I keep forgetting the name of that other band. Where Johnny Baldridge. So between Johnny and Anna, so Johnny, the max profit was 36,000, but for Anna's Animals, it was 36,125. So I would go with Anna because she's going to give us the maximum profit. Okay? All right, and then later today, you guys are going to do the Ready, Set, Go. There is a video that can go along with the Ready, Set, Go in case you're getting stuck. But today's lesson was really all about interpreting two different ways to look at a function. So factored form, standard form, knowing which one gives you what. I do want to talk about, let's go back up to Johnny, because I don't think that we said this, that Johnny was in factored form, and factored form immediately gives you your x-intercepts. And it also gives you where your axis of symmetry is, because you know the axis of symmetry is going to fall between those 2 points. So if it falls, I think it was 100. So what falls between 100 and -20? So you just do midpoint. Sorry, my handwriting's getting bad. So 100 it's plus -20 divided by 2. And so that's going to give you 80 divided by 2, which gives you 40. So factor form can give you x-intercepts, and it can also give you your axis of symmetries, so knowing where your vertex is going to be. And then in standard form gives you your y-intercept and your direction of your parabola, positive or negative. All right, so that's all I have for today. If you have any questions, make sure you ask myself, Miss Garwood, or Miss Ruff. And if there are any mistakes, just email me and let me know. All right, thank you so much, and I hope you guys have a wonderful day.